Hi students, welcome to physics class. In this video, we are going to discuss about free fall. Free fall, free fall, and discuss the motion of discuss the motion of an object under free fall comma neglect air resistance once again free fall. Discuss the motion of an object under free fall. Neglect air resistance. This is today our concept. So I would like to explain point by point. Please observe carefully. Now, point number 1. An object released near the near the surface of the earth. Surface of the earth is accelerated downwards. Is accelerated downwards under the influence of the force of gravity. The force of gravity. Now once again I am repeating the point. An object released near the surface of the earth is accelerated downwards under the influence of the force of gravity. Now point number 2. The magnitude of acceleration due to gravity is represented by small g. If, once again, the magnitude of acceleration due to gravity is represented by small g. Point number 3. If air resistance is neglected, if air resistance if air resistance is neglected, comma, the object is said to be the object is said to be in free fall. Once again I am repeating the point. If air resistance is neglected, comma, the object is said to be in free fall. Point number 4. G can be taken, small g can be taken to be constant equal to 9.8 meter per second square. Once again I am repeating the point, my dear students. Small g can be taken to be constant equal to 9.8 meter per second square. Point number 5. Free fall is thus a case of motion with uniform acceleration. Once again, this point is important. Once again, I am repeating the point. Free fall is thus a case of motion with uniform acceleration. Assume now, point number 6. Assume that the motion is in y direction. The motion is in y direction. Choose upwards. Direction. Choose upward direction as negative. That is G is equal to A is equal to minus 9.8 meter per second square. Once again I am repeating the point. Assume that the motion is in y direction. Choose upwards direction as negative. Therefore, G is equal to A is equal to minus 9.8 meter per second square. Now, next point. 7. Choose downwards direction. Downward direction. Choose downward direction as positive. Positive. Therefore, G is equal to A is equal to plus 9.8 meter per second square. This is about free fall. Now, equations. Equation of motion. Motions become as here upwards direction. Upward direction. Here downward direction. Downward direction. Now take V is equal to U minus GT. Here V is equal to U plus AT. Here S is equal to UT minus 1 by 2 G T square. Here S is equal to UT plus 1 by 2 A T square. Here V square minus U square is equal to minus 2GS. Here V square minus U square is equal to plus 2GS. Fourth one, S nth is equal to U minus A by 2 into 2n minus 1. Here S nth is equal to U plus A by 2 into 2n minus 1. Now free fall. Free fall. U is equal to 0. A is equal to G is equal to plus 9.8 meter per second square. Here V is equal to 0 plus gt, S is equal to 0 plus 1 by 2 g t square, V square minus u square means 0 square is equal to g s. This also we can write it as V square is equal to g s, and also s taken as h. Therefore V square is equal to g h. V is equal root 2 g h. S nth is equal to 0 plus z by 2 2n minus 1. Now these equations give the velocity and the distance traveled as a function of time, and also the variation of velocity with distance. Now once again these equations give the velocity and the distance traveled as a function of time, and also the variation of velocity with distance. Once again, free fall. Definition. An object is accelerated towards surface of earth. Under the influence of gravity. is called free fall. Once again I am repeating the definition. An object is accelerated towards surface of earth under the influence of gravity is called free fall. Now the graphs of variation of acceleration velocity and distance with time. Now our concept is the graphs of variation of acceleration, velocity and distance with time. Now go for the graph number 1. Now take negative y-axis, take positive x-axis. Here I took time. The time is in the seconds. Here I took acceleration upward direction A. Consider here is -10. Consider here is -5. 0. Origin. If suppose I draw a straight line which is parallel to positive x-axis. Now consider it is -9.8 meter per second square. What this graph shows? This graph shows variation of acceleration with time. That means this graph shows variation of acceleration with time. Now graph number 2. I took a positive x-axis and I took minus y-axis. Here is -40, -30, -20, -10, 0, 1, 2, 3, 4, 5. On y-axis we took velocity. Now if a graph is like this, on x-axis we took time. Okay? Now what this graph shows? This graph shows variation of velocity with time. The above graph or the graph shows variation of velocity with time. With time. Now, graph number 3. Graph number 3. Take positive x-axis and on the x-axis I took time. The time in the seconds, in the form of seconds. Here I took negative y-axis. On y-axis I took distance. That distance is in the meters. Here I took 90, 80, 70, 60, 50, 40, 30, 20, 10, 0. If the graph is like this, half parabola, in this case, what we understood? We understood that this is the variation of distance with time. That means the graph indicate variation of distance with time. Variation of distance with time. Dear students, in this video we discuss about free fall and special cases and 3 graphs. I hope you understood this video. Thank you very much for watching this video. Thank you.